안녕하십니까. 제로원 김차입니다. 오늘은 2021년 12월 17일이고요. 요즘 제가 열심히 코딩하고 있는데 패러렐 알고리즘을 거의 다 완성했어요. 슈퍼 초강력 패러렐 알고리즘을 만들고 있는데 거의 다 만들었거든요. 이제 하나만 더 만들면 되는데 이거 만들다가 갑자기 생각이 안 나는 거예요. 제가 만들려는 게 어떤 거냐 그러면 다차원 패러렐 알고리즘이거든요. 그러니까 1차원 패러렐 알고리즘이 아니라 여러 개의 차원을 주면 거기에 맞춰서 자동으로 다차원 패러렐 알고리즘을 생성해 주는 거예요. 근데 이걸 코딩을 하려니까 갑자기 생각이 안 나요. 옛날에 굉장히 열심히 설명을 드렸거든요. 저 영어 채널에서 C++ 템플릿 메타 프로그래밍 27번과 28번에서 멀티 디멘셔널 매트릭스를 동적으로 생성을 해요. 그래서 이렇게 만든 동적 멀티 디멘셔널 매트릭스는 1차원, 2차원, 3차원, 4차원, 5차원, 6차원, 7차원 차원에 제한 없이 매트릭스를 만들어줘요. 그러니까 멀티 디멘셔널 동적 배열을 자동으로 만들어줘요. 근데 이거 이론이 좀 어렵거든요. 어렵다기보다는 이론 자체는 쉬운데 코딩하기가 좀 애매해요. 처음 하시는 분들은 이거 좀 어렵게 느껴지거든요. 이 코딩 하다 보면 이런 문제 굉장히 자주 부딪혀요. 그래서 하루는 열받아 갖고 제가 이 이론을 아주 자세하게 어떻게 계산하는지 코드까지 함께 제공하거든요. 이 동영상에서 설명하는 내용은요, 거의 언제나 항상 always 항상 사용하는 프로그래밍 기법이에요. 지금 제가 패러렐 알고리즘을 다차원으로 만들려니까 제가 이거 옛날에 동영상 안 찍어 놨으면 또 한참 생각을 해야 돼요. 저도 이 동영상 다시 보고 저희 고 패러렐 이걸 다차원으로 구현할 거거든요. 제가 이렇게 동영상을 안 찍어 놨으면 또 한참을 생각해야 됩니다. Hello everyone, my name is Thomas Kim. Today is 24th of January 2019. This is 27th episode about template meta programming. In this episode, we will implement multi-dimensional matrix in C++ or dynamic multi-dimensional array. In Visual Studio Code, I create a file, talkplayfun, matrix, cpp, include IO stream, include vector, template, type name, element type, class, matrix, public, using element t, element type. We will create another data type using dimension t, std, vector, size t, then another one using array t, std, vector, element t, then private dimension t m d, dimension t m m, array t m e. This holds for dimensions of the array or matrix. Multipliers for indexing. I will explain more about this array, the elements of the matrix. Public, we declare matrix. This is default constructor. We will make more settings here. Then we create template matrix, template, type name, dim type, type name, dim types, then matrix, dim type, dim1, dim types, dims. Now we are at this point. We will first build this matrix like this, M, D. We are assigning elements like this, static, cast, size T, dim1, static, cast, dims, size T, dims. So we assign this matrix, dimension matrix like this. Now we need to calculate multipliers. Suppose a matrix 3, 5, 5 matrix, rank is 2 and dimension D0, D1 equals 3, 5, 5. The total number of elements is 3 times 5 or D0 times D1. I hope you understand this concept. Now let's think another matrix. 3 times 5 times 7. Rank is 3. Dimension is D0, D1, D2 or 3 by 5 by 7. The total number of elements is 3 times 5 times 7 or D0 times D1 times D2. You understand this concept? Now let's try another matrix. Matrix 3 times 5 times 7 times 11. Rank is 4. Dimension is D0, D1, D2, D3 or 3, 5, 7, 11. And the total number of elements is 3 times 5 times 7 times 11 or D0 times D1 times D2 times D3. Okay, I will make it a little bit shorter like this, and also this I arrange like this here too. Let's think about the two-dimensional array. I copied and pasted it here. We'll be thinking about two-dimensional array. For element, E is element, we want to access two fourth element of this matrix. This matrix 3 by 5 matrix, we want to access 2 4 element of this matrix. Then we have to calculate address like this. First, this is lowest index is 4 times 1 plus then this index 2 times this list dimension D1. Okay, 5. We have to calculate like this. Okay, this is address of this element. Now let's try one more. E we convert it into index I0, I1. Then in this case it becomes, I copy this part, I copied it here. 4 is the first index, this I1, so I replace it I1 like this, and this 2 is the I0 index, so I change it to I0. Okay, this 5 is this number 5, and this is D1, dimension D1, so I change it like D1 like this. Okay, this is the way we index element, calculate address of this index. Okay, now let's think about three-dimensional case. I copy this one and paste it here. Now let's think about element 2, 4, 6. Okay. Then this is lowest dimension, index of dimension. This is 6 times 1 plus, now this index 4 times this dimension d2, or I would say just 7 plus, now this index 2 times, we have to multiply 5 times 7 like this. Okay, now let's think about E, I0, I1, I2 index. We want to calculate this address. Now I copy this part, paste it here. 6 is the first index, the highest index I2, so I change it I2. Now this index 4 is the next level index I1, so I replace it I1. This index is highest, lowest index. This is actually highest index. This is I0, so I change I0 like this. Now let's think about this number 7. This is D2, so I change it D2. This is also D2, 7 is D2. Let's think about 5. 5 is D1, so I modify like D1. Okay, so this is I0, I1, I2, D1 times D2, D2, 1, like this. Now let's think about this matrix, rank 4 matrix. I copy and paste. Now let's think about 2, 4, 6, 10th element. We calculate address of this element. Okay, these are address calculation method. We are calculating the address of this element. First we start with lowest index. This is 10. Okay, times 1, then plus the next index. This index is 6 times, then this dimension 11 here, then plus, then this dimension 4, this index 4 times, then we have to calculate multiply this part like this, plus, then this is 2 multiply. Now we have to multiply this part. Okay, I copy it like this. Now let's change it into index I0, I1, I2, I3 like this. I will arrange this, then I copy this part, I paste it. Now let's start with this one. 10 is the first indexed I3, so I modify I3. Okay, the next index, this is the next index 6, I2, and this index, this is the highest, the next level index. This is 4, I1. This index is I0. I modified like this. I will make some space for better reading. Now let's start with 11. 11 is D3, so I change D3, and this is also D3, and this is also D3. Now let's think about 7. This is D2, so I change it to D2, and 7 is D2. Now let's think about 5. 5 is D1, so I modified like this, D1. Okay, so this is I0, I1, I2, I3, and D1, D2, D3, D2, D3, D3, and 1. Okay. Now I will collect them. So this is two-dimensional array. I copy this part here. Then this is three-dimensional array indexing. I copied again. And this is four-dimensional array. I copy again like this. I will arrange these equations a little bit like this. Okay, it looks much better now. Now this is two-dimensional case. This is three-dimensional case. This is four-dimensional case. I will copy these once again. I copied and pasted again. Now I introduce I0 times M0 plus I1 times M1. I introduced the new equation like this, and here also I0 times M0 plus I1 times M1 plus I2 times M2, and here again I0 times M0 plus I1 times M1 plus I2 times M2 plus I3 times M3. Okay, this is two-dimensional case. This is three-dimensional case. This is four-dimensional case. Please note that this M0 amounts to D1. This M0 amounts to D1 times D2. This M0 amounts to D1 times D2 times D3. Here, M1 amounts to 1. M1 amounts to D2. M1 amounts to D2 times D3. M2 amounts to 1. M2 amounts to D3. M3 amounts to D1. Okay. Also note that M1 is 1. M2 is 1. M3 is 1. I copy this equation once again. Copy and paste it. In this equation, I will remove I0, I1, I2, I3. I will remove them like this. I removed one again and again like this. Also, I will remove I0, I1, I2, then I3 like this. And I will remove this plus 2. I rearrange like this, and here too like this. From M3 and 1, I make equation like this. M3 equals 1. This equation. Now M2 equals D3 like this, and M1 equals D2 times D3, D2 times D3, and M0 equals D2 times D1 times D3. I copy and paste like this. In this equation, I will multiply 1 like this. Then here in this equation equal D1 times D2 times D3 is M1, right? D2 times D3, D2 times D3 is M1. So I can let it like this, M1 here. Now D2 times D3. D3 is M2, right? So M2 here. This is D3. So D3 times 1 is actually M3. So I can put M3 like this. And here 1. And I will copy this code once again. These equations once again. I copied and pasted it here. Now here I will let M0 equals 1 like this. This is initial state. Then instead of doing this, I can say M0, right? Now I copy this part of code once again like this. And we will remove intermediate parts. I will remove all intermediate parts like this. Removed. Also removed. Also removed. Also removed. Okay? I hope you understand this point. Then I paste it like this, a space. And here M0 equals, I copy this text, copy and paste, then enter. Then instead of doing this, I can put M0 like this. And here too, M0, and I copy this text, copy. Then here I put M0 like this. Okay, and here too M0 equals this text here. Then I don't need to calculate anymore here. This is the end of our calculation. I put a marking here, delimiter. Also here delimiter. Also this is end of our loop. I will copy this part of code once again. I copied and paste here. Please watch carefully, okay? Here in this equation, M3 is actually M0. Okay, this M0 is M3. M3 is M0. So this equation is actually identical like this. M0 multiply D3. Okay, this equation is actually identical like this. Okay, and here also M2 is M0 here, and this is M0 new M0 becomes this is M2. M2 is actually M0, so it can be like this, okay? Here also M1 is actually M0. This is actually like this, okay? So I will restore it like this. I will rearrange the same equation like this. M0 multiply D3. Okay, and here this is the same equation, M0 multiply D2. Okay, also here M0 multiply D1. So I will copy this equation once again. I copy and paste. I finalize it. This is M0 equals 1. In this equation can be modified like this, okay? And also this equation can be modified like this, and this equation can be modified like this. And for your reference, I will copy them like this, and I will copy this part like this, and I will also copy this part for your reference. So I save them. Now we are making it into a loop. Okay, we are making it into a loop. Outside of loop, m0, this is m0 equals 1 outside of loop. For size tn equals, please note that this is rank. Rank is 4. This is 4-dimensional array with d0, d1, d2, d3. 4-dimensional array. Rank is 4. Okay, so it should start with 3. Rank minus 1. Okay, rank is 4 minus 1. It should start with 3 because rank is 3. 4. Rank is 4. So 4 minus 1, it becomes 3. So it is the index 3. Okay, then n should run until 1. 3, 2, 1. So n should not be 0. Okay, or we can say n should be greater than or equal to 1. We can just say n should be greater than or equal to 1. 3, 2, 1, like this. Then we decrease 3, 2, 1. We are decreasing n like this. Okay, so inside this loop, this is the loop. Okay, so m n, this means m3, then m0, like this. Then we are calculating this equation. So m0 times d3. This index is n. This index is n. So dn, like this. This is the loop of calculating this m, values of m. If we calculate this m0, m1, m2, these are multipliers. Okay, if we calculate the m0, m1, m2, then we can calculate index like this. I will copy this part. If we calculated m1, m2, m3 here, we can calculate the address like this. E, I0, I1, I2, I3. Then we can calculate m0 times I0 plus m1 times I1 plus m2 times I2 plus m3 times I3. We can calculate our index, our address like this. Okay, another thing you should note is that I will save this. Please, let's go back to this equation. Please note that this is four-dimensional array. In this case, rank is 4 and dimension is d0, d1, d2, d3. This is four-dimensional array. So m0 multiplies d1, d2, d3. So the total number of elements should be m0 times d0, or I would say d0 times m0, d0 times m0, because d0 times m0 is 1, 2, 3, 4, 5, like this. Okay, so if we want to calculate the total, then we have to calculate d0 times m0. This is the total number of elements. I will copy this text. I will copy it. Then here we can calculate the total number like this. Then here d0 times, we calculated m0 at this point. At the end of this loop, m0 is calculated, so we can calculate total element like this. With this information, we will code. Hello everyone, my name is Thomas Kim. Today is January 24th, 2019. This is my 28th episode about template metaprogramming. In this episode, we will learn how to implement multidimensional matrix in C++ or dynamic multidimensional array. This session continues from my previous video, template metaprogramming 27. If you haven't watched this video, please watch this video. In this video, I explain the detailed theory behind multidimensional dynamic array. In this session, we will not talk about the theory, but we will use what we learned in our previous session. Also, in this session, I will use the concept of class invariant. Class invariant is explained in the C++ programming language post edition. You can refer to this book. More about class invariant, please refer to this great book by Van Strostrup, the creator of C++ language. Okay, let's get started. We will create a function called allocate array. Please note that this DMD, MD means D0, D1, D2, etc. dimensions. And here we now calculate multipliers MM. I will copy theory from our previous sessions. I will copy this part of code and paste it for your reference, and I will make them comment out. Now first we need to calculate rank. Size T rank is the dimension of MD, the size of MD, like this. This gives the rank. So we determine the rank. Then we allocate memory for MD, MM, like resize. Then it should be rank. We first allocate memory for multiplier. Then this M0, it should be initialized to 1. So we are applying this code. Then for size T n equals rank minus 1, rank minus 1. Then n should be greater than or equal to 1 and minus n. This n should be this n0. This n0 means multiply this mdn. So we are applying this rule. Okay, I will copy this code for your reference, and also this. Then at this point we calculated all multipliers m0 and m1, etc. Then we need to calculate total size T total. In our previous session, the total size is calculated like this. Copy, and I paste it here for your reference, like this. Then this md0 times this mm0. This is total count. Please note that this should be at least greater than 1, greater than or equal to 1. So we assert total should be greater than or equal to 1, like this. To use this function, we have to include C assert. Okay. Then we allocate the memory. Now we initialize. So we allocated this memory. We computed mm. Now we have to initialize we allocate this ME elements for matrix, like this. This me resize total like this. Then I will create another function, void initialize. Then like this, we initialize all elements of the matrix to default value like this. Size t total. Now we can get this me size. Okay. Then for size t n equals 0 n less than total plus n. Then this me n, the type of this element is element type t here, element t. Then we copy paste like this. We initialize all elements. Then we can call like this, initialize. Okay. In certain case we do not want to initialize, or we can just disable it. Just we do not initialize, or we can put it in public section. We do not initialize by default. We allocate memory, but we do not initialize. With this, we almost done. So now we implement some operators. Indexing operator. I will copy this part. I paste it. Then I will change it to index type. Then also I will change it to index type. Then element t operator, I modify like this. Index type, I would say idx1, and index types idxs. idxs means index. I will unindent a little bit. Now we build index dimension t. This is index. Then static cast size t idx1 static cast size t idxs. Please note that the number of index should be equal to the number of dimension. So we check like this. Assert index size should be same to this md size. Okay. Now we can calculate address like this. Size t add ress 0 for size t n equals 0. I will create rank here. Rank is this md size. Okay. Then n should be less than rank plus n here. Add ress this n times this index n. So here we are applying this rule. We are actually applying this rule. Let me see this rule. Okay. I will copy this and paste it here. So we are accumulating address like m1, mi. This is m0, m1, m2. This is index is i0, i1, i2. Or I can simply say here like this, and I can change like this. Then it can be simply I. Okay. So this is the address. We calculated the address. Then we can now access the element like this. me add ress. So we are using this operator this parentheses as the index operator. Now this function is done. Here, let me see. In this function allocate array, we have to fix this mm. Also here, we have to fix mm like this. Then now let's create invariant function for invariant. In case array is 0, this does not work, so I create a function invariant. I create a simple function like this. In this case, this md resize 0 1, this is one element. Then this md 0 should be 1. This resize 1. This 0 should be 1. This me resize 1. This me 0 should be element t default constructor. This is invariant, so we call from this default constructor. Now we will also have resize function. I will copy this part. No, this part copied, and I change the function name void resize like this. And here I will simply call this function. I forgot calling this function, I think. This function copy, and here we have to call this function, and also we call this function. This resizes the dynamic array. And also I will give some more functions. Size t total returns total elements count. Return this me size, it should be constant. And rank size t rank constant. I will make it constant reference, constant size t reference like this. Also constant size t reference. In this case, return this md size. And we also make some functions. Constant size t dim template type name dim type. I say dim index type dim index type dim idx. Here return this md dim idx. I will not check the bound of the array. Save all. So I made dimension function returns dimension of the matrix, returns the rank of the matrix, returns total number of elements of the matrix. I will make one more operator. I will copy this part only. In some case we want to access elements like this. Operator like this. Template type name index type idx. We simply return this me size t idx. We do not check the bound. Then I will create two functions. Actually, I don't like this method, but I will just do this. Constant. Also, actually, I don't like doing this, but I will just do this because I feel bored. Constant. Okay. Or we can make a function, member function like this. Copy. I copied. Then here, access. I created a function access here. Then I call this function. Instead of doing this, return access idx1 idxs. We simply redirect like this. Also, we do once again like this. We simply redirect because I don't like to create two functions. This is for non-constant, this is for constant. Okay. Then I will just let it do. Sorry, I think this approach will not work because this is non-constant function and this is constant function. Constant function cannot access non-constant function like this way. So I will modify a little bit like this. I will change it constant, and instead of doing this, it will return size t, and I will change the function calculate address. This function simply calculates the address, then it returns the address address. Okay, this function does not access the element directly, it only calculates the address. So here, after accessing the address, calculating the address, then we can return like this. This me calculate address, then idx1 idxs like this. I fixed like this. Then it is constant function, so it can access from non-constant function, both in non-constant function. Then I copy this part once again. I copy again and paste it here. So it should work now, and it should work. Also, about this array indexing, I will make some changes. I will find and change array indexing. Find next. It's okay. Okay. I am fixing some indexing problem warnings probably. Here I will change it to typecasting. Here size t, and I will copy this part. I copied. Then here next. Okay. Now let's implement copy constructor. Here I will create a copy constructor like this. Then here I will delete this, and constant matrix will make it default. This is copy constructor. If it doesn't work, then I will fix it. Then copy assignment matrix operator. This is copy assignment. Then move constructor. Move constructor is a little bit more complex. This is move constructor. This is right. Then here, if this is not std address of, I think this function is in utility, include utility. I need type trace. Okay, now scroll down here. Address of right. Sorry. Then we are moving this d std move right d this std move this right this e std move right e. Then don't forget this right invariant. We have to call this function. Then return this. No, this is copy constructor. This is move constructor. Move constructor. I have to fix this part here. Right. And I copy this code, cut, paste, like this. In this case, I can simply do like this. D std move right d std move right me std move right me. Then here right invariant. Now we implemented default copy constructor, default assignment operator, then move constructor, move assignment, then we will create swap, void swap constant matrix no except this MD swap I would say no, I cannot do this. I will do this. MD. We just swap this MD swap M this ME swap ME matrix. I will change like this. Return this. Now we will implement output operator here. Friend std o stream operator std o stream os constant matrix m size t total me size. I will -1 size t r md size. This is rank. I will also -1 here. os we print the first element me 0. This is the first element. Then we display the last element os me total. This is the last element because we -1 in between for size t I equals 1 because we display the first element here. Display first element. So we start with 1 I less than total plus I will introduce bool b no new line true. For size t j equals 0 j less than r. Please note that this is rank size -1 r. I will change it like this, rank like this. Okay, so to make it clear like this. Then ++j we are handling line break. If I modulo j equals 0, it means we need to have carriage return. os we make carriage return b no new line true. No, false. We are still inside of the loop. If b no new line, it is true, then os, then we display os e I like this. Then here I will make more changes. If total greater than 1, like this, I fix. We have to put one more space, OS, like this. Okay, and we have to return OS. Return OS. So we created a friend function. Now int main. We will first create a matrix double A. We will default to 3 by 4. Then size t dim 1 A dim 1. Have we defined this function? Let's see. Dim here we defined, and the size t dim 2 A dim 2. I think it is in private section. Let's see. It is not in private section. Why it's not displayed? We can put like this. Dim. Okay. Let's try. For size t I equals 0, I less than dim 1 plus I. For size tj equals 0, j less than dim 2 plus j. A ij b. I will define like this, double b 0, then plus like this. Now we display the result. std cout A is std and there std cout A std and there. Now let's build. Enter. Wow, it built without error. G. Wow, what's wrong? Values are not set. We assigned the value, but it is not set. Let's check what's the problem. Sorry, I made a silly mistake here. Then it should assert. I think I have to fix like this. Then let's try to find more assert. Total greater than or what? I think I also have to change like this. Like this. It's not working. And next. Okay. Then I will try again. This time I will use Microsoft compiler CL EHSC std C++17 talk play fun matrix cpp fe mexe. It should assert okay, it asserts successfully. Why it asserts? I will disable it. Try again. Okay, now it asserts 143. 143. It asserts here because I provided the wrong dimension. I have to fix like this, 0, 1, and I have to fix another one here. I have to change it to 0 because we minus the 1 here. Now field once again. M. What's wrong? Okay, it works. Now let's try with the GNU compiler. G. It works. Now let's try with Clang. CLAN. Okay, it all works. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 elements. Because we provided 3 by 4 to 3 by 4 two-dimensional array. Now let's try with B, and we will copy. We declare B, and we will copy B. Now let's see if copy assignment works. Then we display both A and B. This is to test copy assignment. B. This is A. Let's try with Clang. G. This is A. This is B. Okay, copy assignment works. Now let's try move assignment. This is before move assignment. Then std move. Then after move, I will copy this. This is before move A. This is after move A. Now let's run this. Okay, this is before move A. A is displayed. After move A becomes null. B is moved successfully. So this session we learned some basics about multidimensional array. In next session we will finalize this matrix operation. We will implement operators like matrix addition or matrix with scalar multiplication, things like that. And I will also explain how to optimize this matrix class in next session. Please subscribe to my YouTube channel. Thank you for watching.